Alright, so for the first video here, we're going to do the intro notes, number 1, and I'll just kind of talk you through them, and you can follow along and fill in, and you can skip forward if you want, or you can move back if I'm going too fast. So what kind of data could we gather to determine if we have a healthy class? So we're just kind of brainstorming here, and we could come up with a lot of things. We could measure blood pressure. We could ask people about their eating habits. We could have people report their weight. We could have people report the number of hours that they sleep each night, things like that. So let's suppose that everyone in our class records his or her pulse rate over a period of 60 seconds. What kind of statistics could we look at? So we're going to gather some data sets by doing whatever thing here that we decide to do to determine if the class is healthy, and then we can calculate statistics on that data set. And there are different statistics we could calculate. Probably the one you're most familiar with is maybe just taking the average of whatever set of numbers we have. There are lots of other things you can do with those numbers, but average is probably the one that you're most familiar with, followed probably by taking the median and possibly even looking at the mode, whichever one happens most often. For this unit, we're going to focus on the mean, which is going to measure the center of the data, and then something called standard deviation. Okay, and standard deviation is going to be a measure of how spread out the data is. So mean is defined as the arithmetic average of all the data. And that's calculated the typical way. You add them all up and you divide by the total number of things that you have, just like you do your average in Algebra 2. The notation for mean, there are two different symbols. One symbol represents the mean of a sample, and that's going to be an X with a bar over it, and you pronounce that X bar. And the other symbol is for when we are talking about a population, and that is mu. It is spelled mu, but it is pronounced M like it's M-E-W, kind of like a cat. It is a Greek letter. And so we have these two different symbols because in statistics we need to know whether the number that we're talking about was calculated for just a sample, right? Was it calculated for just the data set that we're looking at, or is that a generalization that we're making for the entire population? So what we tend to do is we will take, it's unrealistic to survey maybe everybody in the population that you're interested in. So maybe we want to calculate a statistic about all students in Algebra 2 at DB. Well, it would be much more time consuming to survey every single student rather than to take a sample of the students in Algebra 2. And so maybe we would take one classroom and we would survey that one classroom, and then we would make generalizations about what was likely for the whole population based on what we saw in that one classroom. So the classroom would be the sample, the whole population of Algebra 2 students at DB would be what's called the population. Okay, so standard deviation is the other statistic that we're going to talk about in this section, and standard deviation is the average distance the data is from the mean. And the notation for standard deviation also has two symbols, one for the sample, that's just S, or sometimes it's S sub x, and then a different one for the population, and that is the Greek letter sigma. So in statistics, if we see Greek letters, we know we're talking about the population, and if we see the typical letters that you're used to seeing, Arabic letters, we are talking about a sample. So let's look at this example right here, and we are going to do most of this stuff on the calculator. So if you take your calculator, and we want to go into Stat, and we want to edit. We want to enter this data right here into L1. So I'm just going to enter it. You need to be kind of careful to make sure that you enter everything correctly, because if you mess up a data point, obviously your answer will be different. It can be a little tedious, but it's just important that the data entry is correct, or else everything else gets thrown off. And so we can see that in this example there are 32 ATM withdrawals, and so you can see right here in my calculator it is showing that I have entered 32 items into the list at that point. So I have entered them all, and so now we are going to calculate some statistics about that data set. And so in the calculator, if we go back to stat, and now we're going to calculate, we want to do one variable statistics. It's going to show us a lot of different statistics, some that we need and some that we don't need. So you can see if you go down, it'll tell you the minimum value in the list was 10, the maximum was 80, the median was 30. Q1 is, of course, the median of the first half of the data, and Q3 is the median of the second half of the data, and you would use those 5 numbers to draw a box and whisker plot if that's something that you wanted to do. N equals 32 is telling me that I have 32 items in my list. And then you can see the sample mean and the sample standard deviation right here. And so this is just a screenshot of what has just been calculated. So the sample mean is X bar, which is 34.688 if we round. And the sample standard deviation is 20.981, and that's coming from right there. And the rest of those statistics that show up on the screen are not things that we are going to use in this unit. Alright, if we want to sketch a scatter plot, we can also do that on the calculator. So we need to go into the stat plot right here, just like we did for scatter plots. And right now you can see all my plots are turned off. I want to go in, I want to turn one on, but I want to then go over to the histogram looking thing right here. So I want to select that. We need to make sure that my X list is L1, that's the list that I just put the data into, and that the frequency is 1. And then again, just like we do with scatter plots, if we go to zoom stat, it will take us directly to the scatter plot. And so you can see this is a screenshot of what is on the calculator. So if you want to see some information about that, you can actually take your calculator again, and you can hit the trace button. And you can see right here it's telling you the minimum value in that interval is 10. So this line right here would be 10, and then it goes up to 21.66. So this is 10, 21.66, and then it also is telling me that N equals 11. So there are 11 items in that range. If I go to the next bar, I can see that N equals 8, so there are 8 items from 21.66 to 33.33. Right, it's telling you the minimum and the maximum of that interval. And you could go to the next one, N equals 5, and it's going from 33.33 to 45, and so on. Alright, so let's look at doing a couple examples here. Alright, we've got 18 data points that we're going to put in, and we want to find the mean and the standard deviation and then sketch the scatter plot. So we need to go back to stat and edit, and we're going to clear this list out. So go highlight L1, clear and enter, and then we want to enter this data. Alright, and so I've entered 18 things. I'm going to go to stat, calculate one variable statistics, and my sample mean, X bar, is 55.278, and my standard deviation is 13.598. And if I want to see the scatter plot, I still have my scatter plot turned on, so I'm just going to go to zoom stat, and there it is. So I can kind of sketch this. If I just trace, I hit trace right there, and now I can sketch it. So you can see the minimum value here is going to be 22, and the max is 31.4, and the first one is N equals 1. Then I can go over to the next box. Minimum is 31.4, max is 40.8, N equals 2. And then I can go to the next box. And you can just keep doing this for all of your histogram there. So that's the end of the problem. So we can we'll answer this question over here. What is the width of each bar? So that's saying what is this width right here, right? And so you can see that it is 9.4. And you can use your calculator to help you to do that subtraction if you need to. All right, let's look at another example. We'll do the exact same thing again. So we'll go into Stat. We will clear out what is in there. And we will enter this new set of data. There are 14 data points here. And I actually have one of my data points is wrong, so hold on, let me fix it real quickly. This needs to be a 75. All right. All right, I think I may have missed one, so we'll go back and check. 63, 75. Yeah, so I missed a 66. It doesn't matter what order you put these in, so I'm just going to add it to the end right there. All right, so I can see I have 14 data points here. I will calculate my one variable statistics. So X bar is 69.214. Standard deviation is 3.239. And I can now sketch my scatter plot. So I'm starting at 63 and I'm going to 65.4. N equals 1. Go to the next one. 65.4 to 67.8. N equals 3. Okay, so your completed histogram should look like this, and you can pretty easily see that the distance between each interval is 2.4. So you can add that to your box right over there. Now there's a note here at the bottom. One of these distributions, between 3 and 4, one of these distributions has a special shape that we'll discuss more in the next section, and it is called a normal distribution, and sometimes it's called a bell curve. So which of these two examples looks like more of like a bell-shaped curve? Hopefully, you think that example 3 looks that way, and so you can kind of see the bell shape to the curve right here. And we're going to talk a lot more about that in the next section on the notes. Right now we're going to go to the back page here, and we're just going to do a little bit of a summary and some vocabulary back here. So you should be able to now sketch a histogram with your calculator. And when we're talking about shape, there are a couple things that we want you to look for. We want you to look for, look at these 3 pictures. So these are shape descriptors for different histograms. So sometimes a histogram looks normal like this, and it has a symmetric shape. So you can see that it's kind of symmetric about the mean. So some things that are symmetric or have symmetry, you're gonna look for things that might be unimodal like this, or they might be bimodal like this. There might be some symmetry to this. This one doesn't. It's a little bit symmetric. And then this is what's called multimodal. It's important to remember that with statistics, we're not looking for exact symmetry like we do when we're looking for like an even or an odd function, or we're looking at a polynomial. We're looking for, does it kind of look symmetric? And so this one and this one even does too. They both kind of look symmetric. If you have something that looks like it has a tail to the right like this, that's called skewed to the right. So there's a tail to the right. As the value of the variable increases, they occur with less frequency. And then just the other way, if it has a tail to the left, it is called skewed left. When we talk about center, so shape is one of the things we're going to talk about, and it could have one of these three shapes. When we talk about the center of the graph, we're talking about what value appears to be the average. And then something else we might talk about is the spread of the graph. Remember, that's how far things are away from the median, or from the mean, and sometimes we say that that's how close all the data points are grouped together. So something that has a big spread is the data points are not close to each other, and something that has a small spread have the data points very close to each other. And then you've heard of this term before. Outliers are values that sort of don't typically fit the data. They stand out as being either a lot bigger or a lot smaller. Now, there is a mathematical way to calculate if something is an outlier, but in general, most people just say, oh, that looks much bigger or it looks much smaller, and that's usually pretty sufficient. When we are calculating statistics, there are two different measures of center, right? So we talked up here, some ways to describe histograms are to talk about the shape, center, spread, and outliers of the histogram. But when we're talking about the center, there's more than one way to measure the center of something, right? You can average it, you could line them all up, and you could pick the middle term, and those are both measures of center, and they both have different values at different times. So the mean, or the arithmetic average, is usually best when we have no outliers, and it's roughly symmetric and unimodal. So, things that look like this are best when the measure of center is best calculated by finding the mean. If we do not have a symmetric shape, if we have a skewed shape, it's usually better to find the center by doing the median. And the reason for that is that when we calculate the median, we kind of throw out any really small outliers or any really big outliers, and it kind of accounts for the skewed nature of the histograms. When we are talking about measures of spread or measures of variability, we mentioned in this lesson, we've talked about standard deviation, which is a little bit more of it's a more complicated measure of spread. What you've probably used in the past to measure like how wide is a data set is to simply look at the range, which would be just taking the maximum value minus the minimum value, and that'll give you a very basic overview of, is this data grouped really closely together or is it spread pretty far apart?